It's my pleasure to introduce someone who probably actually needs no introduction. And many of you may have actually heard this introduction at least 8 or 9 times, as Mike has given about that many talks, at least for Jackson Hole. He's also put together and been instrumental in 3 of our field trips: Scotland, Hawaii, and upcoming New Zealand. And quite honestly, Iceland. Long Island, wrong volcano. And quite honestly, none of those trips would have happened without Mike and Virginia on board. Mike graduated from MIT in 1971 as a PhD in solid state physics. He worked at GE from 71 until his retirement 19 years ago. He's published over 100 papers in semiconductor physics. Because of that, he was a fellow of the IEE, which is the Institute of Electrical and Electronics Engineers. It is the largest technical society in the world, almost 500,000 members. And Mike has been active there for 30 years and was actually the president in 2003. Since retiring, he's been pursuing his hobbies of astronomy and photography, as well as extensive travel with Virginia. He's had at least 2 exhibits here in the library of his incredible photographs. He's built an observatory with 3 telescopes to do that. And his talks have encompassed cosmology, astrology, geology, and tonight will be an understandable one in geology. So please join me in welcoming Mike Adler.
Well, thank you, Mike. I'm going to change talks here, and we were having a little trouble with these presentations earlier, but hopefully this is going to go just fine. All right, so tonight's talk is going to be on Iceland and the land of fire, light, and ice. We've been to Iceland actually 3 times, but this talk is going to really encompass 2 of those times. Yeah, the pointer works even. And one was in 2015, and the second one was 2017, which was one of the extended field trips that Mike just mentioned that Virginia and I organized to Iceland. Now, we had done one for Scotland, and we've now, there's another one coming, which is for New Zealand, but this one was interesting because I did the Scotland talk, trip, with a guide in mind, and so Virginia and I did that, and that was great. So I didn't plan on doing another one, and then John Willott just happened to mention that he would, sometime he would love to be able to go to Iceland some point. And I said, well, that's interesting. I've been there, but I don't have the faintest idea of a guide. And so, but we had just been there in 2015, and we had this guidebook, which was a wonderful guidebook. And so I decided, well, I'll give a cold call to the author of that guidebook and see what he has to say. And I expected him to say, I'm sorry, I'm too busy. He's a professor at Reykjavik University there. But he said, no, I'll find someone. And well, we went back and forth for about 3/4 of a year, and he couldn't find anyone that was willing to make a commitment to do this. It was 15 days, long trip. He says, I'll do it finally. So that's what happened. And so we had, we came up with a guide. And the same thing happened for this New Zealand trip. We wouldn't have done that trip either, except Brent said he would love to go. I had no idea, but made another cold call. That's a story we'll save for the future. Okay. So we're going to talk about Iceland tonight. And Iceland, in a lot of the diagrams and all, not all of them, but most of them come from our guide's book on Iceland. And his name is Thorvaldr, but we called him Thor, and that's what it states here. And just to right from the introduction of his book is kind of interesting, so I thought I'd just actually read it, or you could read it yourself. But it says, Iceland is an exceptional natural laboratory where all the principal geological processes can be observed. Nowhere on Earth is the architecture of the spreading sea floor better exposed. It's above sea level. It provides a window into continent formation as it was early in Earth's history, because such continents are likely to have been produced by volcanism of a similar nature to that found in Iceland. So anyway, as an introduction, we'll move on to the geology. And partly due to Mike Schur, actually, you have a role in this particular view graph, or the story here. We got to talking about, well, how did Iceland get formed? Iceland is located, okay, here we go. Iceland is located in an interesting place. It's right along the spreading center of the Atlantic Ocean. And it's located between 6323 and 6630, not quite at the Arctic Circle on the northern end, but very close. It's also spreading, from that spreading center, the ocean is widening by 2 centimeters a year. Iceland is part of the ocean crust that has risen some 3,000 meters above the surrounding floor, and including a total area of 350,000 square kilometers. Geologically, it's very young. The youngest rocks are younger than 25 million years ago. And if Earth was 1 year old, Iceland would be 2 days. The surface has changed dramatically because each year 1 million cubic meters erodes away. But fortunately, or depending on your perspective, Iceland is growing. In spite of that erosion, it's actually getting bigger. So this is the actual story about how Iceland formed. And the prelude was 400 million years ago, when what was the predecessor to the Atlantic Ocean, it's called the Eyjafjallajokull Ocean, disappeared. It vanished, and the North American and the European continents collided. And so there was no ocean, and the two continents were together. And about 100 million years ago, a volcanic plume formed under what is now Greenland. And that particular plume continues to exist, and it's the most powerful hotspot in the world. It's the largest and most powerful. At about 70 million years ago, this large continent began to break up, and our current Atlantic Ocean began to form. And the spreading rate is somewhere between 2 and 3 centimeters a year. And a new plate boundary was formed at the place where the ocean, it started to come apart, the continents separated. And about 55 million years ago, Greenland moved off, and now we had this hot spot completely exposed, and it started spewing basaltic lava. And since then, something like 10 million cubic kilometers of basaltic lava has emerged. And this has resulted in, this lava ends up in quite a few different places, not to mention Iceland itself, but it also, portions of Greenland have basaltic lava on it, portions of Ireland, and then Scotland. Those of us who are on the Isle of Skye in Scotland, that's the same, that lava came from the same hotspot that has formed Iceland. But between 30 and 40 million years ago, there was still a land bridge between the continents. But then approximately 20 million years ago, the land bridge disappeared because the ocean was continuing to separate, and the island of Iceland was formed at the plate boundary. And Iceland is the only place where the mid-Atlantic ridge is above sea level. So anyway, that's a long-winded story, but that's how it formed. And so Mike, there's a more complete story than you were prompting me on this as to what happened to that hot spot and what did it have to do with. Well, that's the story about that hot spot. Okay, so the manifestation of this mid-Atlantic ridge is currently, you can see in these pictures here, it has several components to it, but it basically runs from the southwestern corner of Iceland all the way up to the north coast. And the youngest rocks are probably under 3 million years old, and they are in this middle area. The older rocks, as you go away from here, either west or east, the rocks get older, and this gets into tertiary, it's all volcanic, but this gets into about somewhere between 3 and 12 million years old rock. Okay, so that's kind of the high level story. And a little more detail. So here we have a diagram that shows from 5 million years ago to the glacial maximum, which is about 12,000 years ago, or 10,000 years ago, something on that order, shows what happened, how the ice, this last ice age happened. But it also shows what's happened to the actual volcanic areas, the active areas where these major faults are, where the mid-Atlantic rift is. And it moved from the west and gradually across, and you can see it where it is right now. It has two branches here, and then it exits on the north coast. And depending on the formation of land on Iceland, there's three different processes that are going on. If the volcano occurred underneath ice and it was buried, what you get is something called pillow lava, and we'll show you some pictures of that. If it's fairly close to the surface, it creates a hill called a Moberg Hill. And if it was above the surface, then you actually get a mountain. And we have all those features exist on Iceland. Then a little more detail on the geology. If in areas that are inactive and it's no longer, the hot spot isn't underneath it anymore, you get a sag, and that forms a syncline where it's dipping. And in the active areas, like pretty much in the middle and the areas I was showing you, you get an anticline where the actual magma is rising. And if the hotspot disappears or it moves away, chances are Iceland is going to disappear because it'll sink down through the rift. But so far, it's not only is it not disappearing, in spite of the erosion, it's actually continuing to grow. Okay, so on to the trip itself. This is the route that we took, and you can pretty much see we follow what's called the ring road around the entire island. We started and ended in Reykjavik on day 1 and day 15. The first part of the trip, and then we went counterclockwise around the island, and I'll show you versions of this as we get a little closer. And I already mentioned this, but Thor Thordarson, who is the professor at the university, author of the Geology Guidebook, was our leader, and we had 23 of our members on this trip. And there's not the full group here. We kind of, this particular day I took this picture, and it was raining, and everybody wasn't here. Some people I think, were back in the bus. But anyway, we're at one of the high points early on in the trip, and it was not a beautiful day. This is our bus, and our bus driver down here was Tanny Travel, and he's a great guy. Here's Thor with his hammer. And here's Thor with a geological map of Iceland, and Virginia helping him on one of the early days on the trip. The first part of the trip we spent on the peninsula, and the first couple of days. Then we went inland and did what's called the Golden Triangle, and then moved on. This is the southwest corner of the Reykjanes Peninsula. This is where it first happens. This is where the Mid-Atlantic Ridge comes ashore, and you're essentially looking at it coming right out of the sea. And here's a manifestation of it. As you can hear, there's this feature where there's a fault the fault is running right through here, and this feature is a manifestation of the Mid-Atlantic Ridge as it's on the shore. There's a similar feature like this about 10 kilometers further east, and in between the two is a graben. That's an area that's a depressed area between the two normal faults. There's one of the faults and there's another one, and so that's the width of the actual Mid-Atlantic Ridge as it exists at the moment. But the spreading that occurs in these faults, either here or on the other side. Okay, and so here's a few more of some pictures. This is John Willott, who was here, and Thor. And here's myself, and we're holding up the bridge between two continents. So this is the North American plate, and this is the Eurasian plate, and Bill and I are holding up the bridge. Kind of hokey, but anyway, there you go. Yeah, and so a little, yeah, this is Brent doing his thing. A little about the type of lava that we have on Iceland. There's pillow lava, which is, I mentioned, is that lava that is formed below the below the water, and it forms these things called pillows. There's also this very viscous lava, which doesn't flow very well and forms these jagged shapes, and we have that. And we also have this ropey, more fluid lava called Hoi lava as well. And the two times we were in, I didn't really mention the time of the year. It was October. This trip was the field trip started in September and ended in early October. The 2015 trip was a little later, and there aren't a lot of trees in Iceland, but there are some. But we got a lot of nice color, and so you'll see that more. So this is some of the terrain that's around on that southwest corner, and this is one of the Mobergs, and this is just a lava field. This is very typical of what the terrain looks like. Here's a manifestation of this fault. It goes right through this particular hill, and so you can see a fault here and a fault here and a graben in between. So these are some pictures of from the first couple of days. Here's Thor and the culvers, and this is something. This is called a hyloclastite. It's a series of embedded lava fragments or clasts that are embedded in lava itself. These are. This is a fissure right here, and these are exit points, little volcanoes and exit points for the fissure. And there's a lot of these fissures that follow. There are many different faults that go through the active area of the island. And these fissures are the source of a lot of the eruptions. In the southwest area, there are active thermal areas you can go. They're not as spectacular as Yellowstone, but they're there. And if you look in the distance here, you'll see that there's actually a thermal plant in the background here. And Iceland generates all of its electricity thermally. It heats down. Reykjavik itself is heated by thermal heat. So now we're moving on to the Golden Triangle, as I mentioned. This is called Lake Thingvallavatn. And it's the largest lake on Iceland. It is also the location of the Icelandic Commonwealth, which was from 930 to 1260. And you'll see that there's some amazing geology in this spot because the rift goes right through here. Unfortunately for the field trip itself, this picture was taken 2 years earlier. It wasn't quite such a nice day. In fact, that picture of the group was taken in this area, so we didn't have quite such a beautiful day. This is just the same picture without the words, so you can get a feel for how pretty the area is. This is that same fault that came ashore. This is here it is again in this particular area, and you can see all the nice. It has a name. It's called the crack of the Almanagi. I am going to have a lot of trouble with these words. So in fact, most of the time, I'm not even going to try to pronounce them with a few cases. But this thing is 7.5 kilometers long and 64 meters wide. And it's caused by the seafloor spreading. And there's a similar one of these 10 kilometers to the east. And that's the Graben area. And during the last 9,000 years, that has subsided 70 meters. This is a waterfall that's pouring into this same area, and This is just a picture of the waterfall. Actually, this was taken on the field trip. It's pouring rain, but you can't quite tell it. This is, again, you can see some of the very pretty colors that exist this particular time of year. And some nice ground foliage as well. And this is Lake Thingvallavatn down at the lake level, and there are trees, and so you can see there's some nice trees. Okay, so we're moving on from Thingvallavatn to the Gullfoss, which is on the Golden Triangle, as it's called. This is a popular thing. If you go to Iceland, you're going to stay there for 2 or 3 days. You'll do this little tour. It's a waterfall. It's about 100 feet high, 32 meters, and it's in a gorge that's 70 meters high. It's been carved through this area about over the last 10,000 years. It moves about 25 centimeters a year. And what happens is the surface lava is a little more resistant to weathering, and so the sedimentary area underneath it gets eroded, and that creates the falls.
Point to the people in that.
Oh yeah, there are some people here, right there. Okay. Yeah, yeah, yeah. And there's a person right up there too. And this nice picture with the double rainbows did not occur on the field trip, but did occur a couple of years ago, and there's some people as well. This next picture, missing a picture here. Well, okay, I guess we're jumping ahead. There's one picture missing somehow. Okay, well anyway, so that's pretty much the first several days. Days 3 and 4, we're off along the south coast and and you'll see there's a lot of waterfalls, and we're getting into the areas where there are glaciers and volcanoes. Here is our bus driver, Anne Mary, in the background. And here's John and Ron Surdam in the bus. And the bus was it was a great bus. We had a lot of room because we're doing a fair amount of traveling, so we didn't have to squeeze in. We had a bus that'll hold I think 40 people, and there was 23 of us. Plus there was a separate van that we had, and so that took some of the load off the bus as well. Here's the first of the, well, at least one of the volcanoes and the associated glacier on top. This one with one of the local residents. This is the first of the big waterfalls along the coast. This is the Seljalanfoss. I can pronounce that one. 65 meters high. It has it actually has a path underneath it, and we didn't do that, but if you can see people over here, and it's very wet. But this area also has another waterfall right next to it, and it has this interesting little crack here as well. This is the next waterfall along the road, and it's called the Skogafoss, and this one is 60 meters high, and again a nice double rainbow. We did have a sunny day on the field trip at this particular waterfall, but we are no longer allowed to go where I took this picture in 2015. So this picture, it's a little treacherous, so anyway, they blocked it off, so you can't do that anymore. This is the area above the waterfall, and you can see the river that's forming, that actually is creating the waterfall. This is called E17. It's Eyjafjallajokull. 17 letters in it. So we'll talk some more about this one, because this is responsible for one of the better known recent eruptions here. And you can also see some of the local residents up here too. Yeah. Okay. Yeah, and we also, not on our field trip, but we visited on this 2017-15 trip, we went to this particular arm of one of the glaciers that comes out from the Eyjafjallajokull. And this glacier is now 1 kilometer shorter than it was in 1930. But again, still very beautiful. And this is just looking the other way, but very typical sky, just very big skies in Iceland. This is the southernmost point on Iceland. It's called Dyrhólaey, and it's 6323 north. And you'll see here that there's expressions of various types of lava. This is a pillow lava that became eroded, so it formed underneath the water. It eroded, so you have this nice little arch here. And this is just some more of the detail of it. This is looking inland. That's the Eyjafjallajokull glacier in the background here.
There are people in that picture.
Yeah. Okay. Yeah. Oh, yeah. There they are. Yeah. A few people there. This was this is something that we did on the field trip. We went to the Dyrhólaey on the field trip too. The weather was horrible, but it cleared up, and we went. This wasn't very far away. What's remarkable about this spot is that it has these balsamic, basalt columns, and this is balsamic columns. And this is a cave that's actually around the corner here that has these basalt columns. Some of the wildlife, a couple of Iceland horses and whooper swans, which are similar but different than our trumpeter swans, but I think the whooper has something to do with the sound it makes, just like the trumpeter does. And here's some more horses. We saw these. This was actually during some kind of a roundup here. And here's this horse was nice enough to pose for us. Okay, so we're moving on along the south coast, and this is we're going into what's called the fire districts, and this is an area. There's the southernmost point, Dyrhólaey, the Eyjafjallajokull glacier. This is the largest glacier here. This is the Vatnajökull glacier. It's the most active. This whole area is the most active volcanic region in Iceland, with over 100 eruptions in the last 1,000 years. And we'll talk some more about it. This area here, this black area, is glacial outwash plain. They call it Sandur, and this is the Sky Deir and Sandur. It's terribly destroying these names. But this area is where a lot of activity has happened and continues to happen. The types of eruptions on Iceland, there are basically two types, and there's pretty much the same everywhere. There's the effusive eruptions, pretty much like occurs in Hawaii, which are just flows of magma that comes out, and it typically is, well, it can be both, I guess, the and the pahoehoe. The other type of eruption are explosive eruptions, and these are actually the most typical, as I'll show you shortly. These are the more typical eruption that occurs in Iceland, whereas this occurs mostly in Hawaii. They do happen, but these explosive eruptions can be extremely dangerous. Something called the pyroclastic flow occurs, which can eject gas and rock. Tepra is called, up into the air very high. It can be as hot, the gas can be as hot as 1,000 C, and it can move as fast as 700 kilometers an hour, which you can outrun. And so if something like this comes at you, you're done for. So this comes out of Thor's book, or actually a presentation he gave that he was kind enough to share with me. This shows the number of eruptions in this upper plot in the last 11,000 years. And so the mafic, the more fluid, metal-rich, low silicon type of lava is the dominant and so that's the dominant. There's intermediate and silicic, but much less of that. You'll notice that the effusive eruptions are in the minority. The explosive eruptions, 1,772 of these in the post-glacial period. So that's the vast majority of what's going on in Iceland, explosive eruptions. The output of this is, so most of the lava that's produced, both lava and tephra, are produced by these mafic eruptions. And these, this DRE is dense rock equivalent. So this is loose stuff that when it's all piled together gets you these kind of volumes. And this is all in percent. So, but you can see most of it is mafic basalt lava, and most of it is explosive. And so here are some pictures of some explosive eruptions. I did not take these pictures. These came from Thor's book. And they're very violent. They represent over 60% of all the events in post-glacial time. They can be quite extensive. This is 1,000 here is 1 meter. This is in millimeters, so 1,000. So this is thickness of these, average thickness of these as a function of distance. And this is the square root of the area, so essentially the lateral distance of extent of the lava. And so these are the various recent historical eruptions over time. And as you can see, these are many meters of thickness over extremely large areas. Now this is a specific eruption that occurred that made a lot of news in 2010. This was the Eyjafjallajokull eruption in April and May of 2010. And so this glacier, which when we saw it, was very benign. It's a shield volcano because of its gentle slopes. It has a small caldera, and its depth, the ice reaches down to about 1,000 meters above sea level. But it has been active for 800,000 years. And on April 14th in 2010, it became active again. And a steam vent started out, but very quickly it changed to, became almost black by that evening, and it was spewing tephra of ash and stones and bombs of different sizes. Tephra has small stuff, medium stuff, and big stuff to altitudes of 8 kilometers above. And the eruptions occurred in 3 phases, continuing until May. And as you may remember, this stuff just didn't stay over Iceland. It extended and it reached the continent, and it caused lots of airspace closures. Where a single closure for 10 days and then partial closures for another 10 days. And these are some pictures taken from the air of this. This was a lagoon that existed before the eruption, and just a day or so afterwards, that lagoon completely filled in as a result. The eruption produced 300 million cubic meters of tephra. Half of it was fine ash. There was also 23 million cubic meters of lava for a total of 330 million cubic meters. And this was enough, would have been enough to cover central London with 20 centimeters of ash. So this is the farm. That is this is a picture I took in 2015 when we were there. It looks very peaceful up there in this farm. This farm still exists. This is a highway sign that shows the very first day of the eruption above it, and amazingly they saved the farm. These are some pictures, which needless to say I did not take, but we're in a museum that we went to on our trip, and shows close-up pictures of the actual eruption. Okay, so that's E17. Now, so one of the very famous eruptions that occurred in Iceland is called the Laki eruption, and this occurred between 1783 and 84, 1 year basically. It was an amazing destructive event. 10 eruption episodes occurred, starting with day-long explosive events that produced like 6,000 cubic meters per second, 6,000 cubic meters per second of ash in tephra, followed by lava flows of 3,000 cubic meters. It occurred on a swarm that was 27 kilometers long, that was delineated by 140 vents and craters. The explosive tephra covered 8,000 square kilometers and produced 120 million tons of SO2, sulfur dioxide. The eruptions began in June and ended in February. The column heights reached 15 kilometers and produced 15 cubic kilometers of tephra and lava. Bad story. These are the various events that are during that period of time along this flow. As you can see where the location is, it's there's the Eyjafjallajokull glacier, and here's the Vatnajökull glacier up here. So this caused a lot of widespread problems, not just in Iceland, but all across Europe and even back into North America. The SO2 produced 200 million tons of sulfuric acid. It's called the haze famine, and it killed 20% of the people in Iceland and 50% of the livestock. But the damage wasn't confined to Iceland. Because of the fact that the cloud rose 10 kilometers above the surface, the atmosphere, the westerly flow, brought it over Europe and deposited it over Europe. And it resulted in what they call an infamous acidic dry fog that lasted for 5 months. It caused considerable damage to vegetation and crops all over Europe. The temperature worldwide decreased by 1.3 C in 1 year. And the famine that resulted from this is thought to be the source of the French Revolution. So. These are some pictures of the area around there. This is the fissure swarm that produced all of this. This is hundreds of years later what it looks like at the moment. Moss has grown over the fields. And here's this was done on our field trip. Thor took us to this what looks like a sunken area, but here he is, by the way, down here. He pointed out, because he researched this, he said this is not actually sunken. This area over here has risen, and this is an area that didn't sink. So anyway, that was part of his research. This is Bill up here taking a picture. That's Keith down in the hole with Thor. Okay, so this is that's kind of probably the most historic and most significant eruption in Iceland. After we left that area, we were in what's called the Katla Geopark, and we visited this particular canyon, as you'll see. This canyon was formed right after the last glacial period, and it basically water from a lake that overflowed created this interesting canyon, and there it is. It's quite spectacular, and we had a pretty nice day to see this. The next picture is just looking the other way towards the sea. Okay, so that takes us to the next phase of our trip. and we are going to continue along what's called the fire districts across this glacial outwash plain and up towards Hoffen, which is on the east, which is at the corner, and then we go over into the east coast where there will be a change. But so the next set of pictures cover that area. We ended up hanging loose for part of one morning because turns out there was a horrendous storm that was hitting our area. It was a tail end to one of the hurricanes, and we waited out the morning because the winds. We were concerned about the bus being buffeted by the winds, and the van, that matter too. So we waited out the storm in this Herfune's guest house. We actually were the group took over this place, and it was very nice. One of our nicer stays.
Great cook.
Great cook, absolutely. Yeah, she was a wonderful cook, and there's Keith and Lisa just chilling out. This is what these, on a good day, this is what these Standor plains look like. They're beautiful, and it's a braided river that's coming down from these glaciers. And this is another picture taken early morning one day of the same general area. Okay, one of the major features, geological features that causes, creates a lot of the geography that you see, a lot of these valleys and in fact, that glacial outwash plain is sculptured by it, is something called Jökulláps. And they occur for a couple of reasons. One is the Vatnajökull has a subsurface lake, and when it fills up, it breaks, and it breaks the dam, so to speak. Then a tremendous amount of water can flood down at once, and this can cause lots of erosion and damage. But the really big one, and this can produce flows as much as 5,000 to 10,000 cubic meters per second, but these can get a lot larger than that. And if it turns out at the same time you get a volcano erupting underneath the ice, it produces a tremendous amount of water, as much as 10 times as much. So you get 50,000 cubic meters per second, and blocks of ice that are as large as 20,000 or 2,000 meter cubes, big chunks. And this happened in 1996, so not that long ago. And as a result of that, 6 kilometers of the road and there's only one road, by the way, that goes along the south coast, and the 6 kilometers of that road were gone. And here's this next picture shows you some aerial pictures of sections that were wiped out, bridges that are wiped out. And this is they left this twisted metal to show you the power of the water and the blocks of ice and junk that came down from here. We were very fortunate. We crossed this area in on this very stormy day, and let me stay with this for a second. We crossed this area that day. We were very fortunate to get over this area because several days later, it wasn't because of Jökull, but it was because of the rain associated with these hurricanes actually flooded the road, and it was closed, and one of the bridges wiped out. So the road was closed for a week, and we would not have been able to continue our trip. We would have had to go back the other way. There's no way around these things, and so, but we were not affected. Okay, so just a little more history of what's going on in this particular area. This is Grimsvötn is one of the volcanoes on the Vatnajökull, the bigger Vatnajökull glacier. It's the most active. It produced 70 eruptions in the last 1,000 years. In 2004, one of the more recent ones, in 45 hours, it produced a 10-kilometer plume and deposited 11 meters of tephra on the surface 3 kilometers away. And this is a picture not of that 2004, but of 2011. You can see this is tephra, and person standing here. that was deposited. But imagine 11 meters of this stuff 3 kilometers from the source. In 2011, it erupted again and produced this particular feature. And it was much larger than the Eyjafjallajokull, even though that caused a lot of news simply because of the air traffic problem. But this particular, this is just what happens in Iceland. Volcanic activity here lasts typically for 60 to 80 years in a period, and then it goes into an equally long inactive period. Okay, so as you go further east, you're going underneath this large Eyjafjallajokull glacier, and there's a big park here. The height of these peaks, the highest peak in Iceland is 2,000 meters, and we were pretty much looking at it up here. And below it is a national park, which we did not visit this time because of the weather, but there's just a picture of the high peaks. This is, again, more basaltic columns. It's called the Svartifoss, and it's one of the very, really spectacular renditions of these kind of basalt columns. They form because of the cooling. When the basalt cools, it contracts and forms preferentially 6-sided structures. It's energy. A minimum energy phenomenon. And as points out in the view, one of the other major best examples of this, of course, is in Devil's Tower right here in Wyoming. This is a picture in the park. That's actually Virginia and I. It was taken by our friends, and some nice foliage. Further east as we go, you get into these glaciers, these outlet glaciers that are coming down from the Eyjafjallajokull, forming a lake. This particular one, once in 1890, was 250 meters from the ocean, and it's now 2 kilometers away. We were very lucky to see a rainbow. Just another picture of the same area. And this is another lake just a little further along on the road. We did stop here, even though you couldn't quite get as nice a view as this. But this is one that we actually did get to. Our guide was really knowing that this was one of the real beautiful features of the coast. We went back one day before we head up the east coast and got to this spot and saw this. So the group on the field trip saw this particular place. So now we're going up on the east coast, and this changes dramatically. We get out of the active area and we go into the much older rock that's 3 to 12 million year old, and there's no active volcanoes on this on the east coast. Here's just some pictures of some of the folks on the trip. You'll probably recognize a number of them. The heirs here, and John Seidel and Peter here. So on the east coast, we're over into this blue area, which is inactive. We're east of the active area. This is called the Estrahorn. It's the Gabbro magma chamber. That's 5 million years old. You can see we had some really, this is a very pretty day, so we were able to enjoy this. This is my screensaver on my computer. This is my desktop. This is that same Estrahorn reflected in the pond here. And then on that, in this area too, on our previous trip, this is where we first saw the northern lights reflected in the water here, and also in the clouds, which is quite pretty. This is another some other northern lights that we saw on that trip. 2 years before. This little cluster here is the Pleiades right there. And this is Capella in the Auriga constellation right here. Auriga. These are, we'll show you some pictures of the Aurora on this trip shortly. This is going along the east coast, lots of big sky. This is a bay. The actual open ocean is off back here. beyond that little dark land spit. So we're on the east coast at this point, and we're moving north. This is one of the towns along that coast. It's beautiful, it's clean. Almost everything in Iceland is beautifully clean and organized. And we leave the coast here, and we're going up this particular valley. You can see the various layers of basalt and another waterfall, and the dikes that have cut through the basalt. This road at this point is dirt, but it's actually in excellent condition. We did visit a power plant, or actually we visited the dam that forms the water for a power plant, and I'll show you where this is. This is the Eyjafjallajokull glacier here. This lake is dammed up right here by that dam, and then pipes of they've developed tunnels all the way down to here where the power plant is, and so it produces 700 megawatts, a total gross head of 600 meters. The actual tunnels are the total length of the tunnels are 73 kilometers. So they're piping this a long way. It was designed primarily for an aluminum plant. And these are just some pictures of the outflow from the dam and the beginning of the water's path down to the power plant. So this is quite a ways inland. The bus, we took a good part of a day just getting up here. So now we're going to be on the north coast, and we'll be spending some time. This is one of the places we're going to spend 3 days in. But we do this loop around this particular peninsula. And that peninsula, and I just show, okay, so now we're back in this active area again, the northern volcanic zone of Iceland. So this is a 9-kilometer canyon that's formed by an amazing, powerful Jökull, which actually eroded right through almost 100 meters of this canyon through all of these geological layers along a fault that runs pretty much north-south. And this is the Dedifoss, which is in that canyon. It's the largest waterfall by volume, and the Jökull that created this whole canyon occurred because of this of a actual glacial eruption underneath the volcano, and it produced a discharge. Look at this, 500,000 cubic meters per second of water. Pretty amazing. And beautiful waterfalls here. This is the Selfoss, which is very close to that. And Thor took us to these, but oh yeah, we also had a little wind on that particular day. and here's a few of us, including myself, trying to stand up to the wind. This is another waterfall that I had never seen before that Thor took us to. This is looking down the canyon and with this very interesting delta right here. So the very end of this, at the very northern end of this particular peninsula, is something called the Aspergi, which is very pretty. It has this beautiful little lake on it, and it's the end of this particular canyon. And here's some of the people in our group doing a little hike that we did on this particular day. We stopped in a town called Húsvík. It's a fishing and whaling center. There's this beautiful church. So this is the last, the Mývatn area is one of the prime areas to go and study geology in Iceland. It's, Thor calls it a paradise of volcanology. Its name is named after the Lake Mývatn, which is the third largest lake in Iceland. It's above sea level by about 230 meters, but it's only 4 meters deep. It's not very deep. It's on the edge of a volcanic system, the Krafla volcanic system, And it's the landscape itself that's formed the lake goes back to about 2,800 years ago when the Eyjafjallajokull volcano erupted. And we'll show you some pictures of that shortly. There's the Eyjafjallajokull volcano right there. This is a picture entering the Mývatn area from the north, Mývatn area. This is the Eyjafjallajokull volcano right here, very interesting. And this is another volcano that's Ludent crater as well. In 2015, we were able to climb up to the top of this Eyjafjallajokull volcano, and it's about 1 kilometer across, and it erupted about 2,500 years ago. This is just a picture without the words. This is like 16 pictures to make a picture here. It's a lot of. This is a view of the Lake Mývatn from the volcano rim, and the next picture zooms in a bit. You'll see one of the features of the lake are these little islets here, and these are called rootless cones. And what is a rootless cone, you might ask? A rootless cone is what happens when you get a flow of lava into the lake. It crusts over, either solidifies and crusts over on the top and forms lava tubes underneath where the lava is forming. Cracks develop in these tubes and you get eruptions from them. But and these cones form, but they're not. It's not like a volcano. The hot source is not underneath it. That's why it's called rootless. The hot source is elsewhere. It's just flowing by. This is a little information about the Eyjafjallajokull volcano. This shows you. This is what went off 2,500 years ago, but it shows the thickness of the deposits as a function of distance away from the center. And this is was another major eruption in 1724 to 29 that produced lava in this area, and this particular volcano called the Viti volcano and its outflow. You'll see in the next picture is a picture of the Viti crater that is all filled with water at the moment. But this area is extremely active, continues to be active. In fact, there was an eruption here in 1975 to 84, and it added more to the same, all this darker purple is new lava that formed in that particular time period, and there's now a processing plant here. And in the same Mývatn area, there's this particular park. It's called Dark Lake, is what that Dim U Borger is. We walked around here, and there's some people right there with umbrellas. And if you look up here, you'll see this little feature here with this hole in the middle. And the next picture shows Virginia with an umbrella standing underneath that. This is another feature, again, in the Mývatn area. It's called the Grotaglia. It was a popular bathing place until 75 when the water became too hot. Just in the 2 years we were there, this was something that we were the only ones there. 2 years later, it was mobbed with people. So this has become very popular. Right over the top of the Grotaglia is this crack. And this is a manifestation of the rift. Of the ocean Atlantic rift. And this particular opening occurred, it was a 9-meter crack that opened in the 75 to 84, what they call the Krafla fires, the eruptions that occurred in that time. A total of 21 rifting events occurred during that period. Similar widening occurred in the 1724 period. And if you look at then this next picture just is looking the other way at actually this, believe it or not, this thing in the distance is a rootless crater, huge. But anyway, The actual motion here is about this, the separation on the average is 2 centimeters a year, which is the widening of the Atlantic Ocean. But it doesn't occur smoothly. It occurs during these major events, events. And so the actual 2 centimeters a year, nothing much happened for 1,000 years, and then you get these 2 events. There you get 9 meters, 7 meters of widening in a short period of time. But the average is 2 centimeters a year. This is the last major waterfall we saw on the trip. It's called the Godafoss. It's not very tall. It's only 12 meters high, but it's quite wide. And the name comes from the fact that a leader in Iceland at year 1000 made a decision to become Christian, convert, and he threw all his pagan statues into the falls, and hence Godafoss. So we've now left the Mývatn area, and we're going further west along the north coast. This was a beautiful spot that Thor took us to on this, what's called the Skaggy Peninsula, with this nice waterfall. It was a little tricky getting out here to take this picture, but that night that we did that, we finally got where everybody had a chance to see the northern lights. And this is actually at sunset. It's you're seeing sunset occurring in the same time the lights are coming on, so to speak. And they changed continuously all night. And these patterns would last for a minute or two, and they would change, and it was quite spectacular. And I felt vindicated because I made a big deal about coming on this trip, seeing the northern lights. And fortunately, it happened. And it doesn't happen every night, because one is you have to be able to have a clear night, and two, there has to be solar activity that creates it. So what's actually going on is that solar particles, charged particles from the sun, are exciting the gases in the upper atmosphere. The green color is oxygen giving away that green color. The reddish color is nitrogen being excited and then recombining and giving away the reddish color. So this is the picture I began the talk with. It's a composite, but you can see the Big Dipper up here. Yeah. So we're moving along. We visited what's called an immigration center. A lot of people either come and go from Iceland, and there's a nice museum here. We spent part of the afternoon. Very pretty, even some flower garden. Big sky again. A little harbor here as well. These are some bird pictures that I did not take, but it was taken by our friend in 2015. So the last part of the trip is on what's called the Sn&aelig Peninsula. It goes out to the west. It is not an active area at the moment. It's still considered active, but there hasn't been an eruption in 1,000 years. But there have been several eruptions before that. The biggest one is out here almost at the very end. And we actually got a picture of that. In 2015, we never saw this. This was all fogged in. And so we could almost see the top of this particular volcano on this trip. This is a high point on the road along the coast on the Sn&aelig, and you get to see what the terrain looks like. Very pretty, actually. I like this kind of country. This is a picture of one of the country churches, the Lutheran churches. All the country churches look something like this. This white with this kind of architecture and red roof. This is another feature on that peninsula. This is called the Kirch. It's a Kirka Fells, but it's a church rock. and it's you can see all the layers. The yellow or the green are sedimentary layers, and the pinkish stuff is various basalt deposits. This is a black sand beach along the coast there. So it's all ground up basalt. We had a rainy day when we were out here in 2015, so we did a tour into one of the lava tubes, and this is the, you walk down the stairway, and it's kind of interesting. You can see some of the features here underneath. This is a splatter cone crater that's actually quite close to Reykjavik that Virginia and I did. You can see Virginia on the left there. Very pretty with all the sort of the fall colors here. It was 8,000 years ago, roughly, about 480 meters high. This next picture is interesting. This is the top part of a lava tube. It's eroded, so the top part of the lava tube is gone, but it's this huge lava tube. This is and just some pretty plants, colorful plants in that area. And then this is the last town we visited before we went back to Reykjavik. This is, we stayed here overnight. This is the Stykkishólmur. And this is obviously a very different church, very different architecture in the town as opposed to out in the country. Beautiful harbor. And a sculpture. And there are more of these basalt columns on this face here. And then we're back to Reykjavik. I don't have any pictures of the inside of this for this talk, but there is a big, huge organ inside. It's quite pretty. The architecture is inspired by basaltic columns. And this is a sculpture along the waterfront. And this is Iceland. This is actually Greenland from the air on the way back. And that's the end of the talk.
Questions for Mike?
Yeah, John.
How long is the perimeter road?
That's a good question. I think it's about 1,000, maybe 1,500 miles, because I think 10 days, 150 miles a day is kind of rough at what it is. We did it in 2015. We did it in 10 days. This trip was 15, but you can see we made a number of 2-night and 3-night stops. And so, yeah. Those are not really long drives. 150 miles. Granted, they're not super highways, but you're not driving all day by any means. Yeah.
Why are those lava tubes empty now? Is there erosion, or is it?
No, they just all emptied out. I mean, it's just all the the gravity. It all left. I had that same question. Why didn't they freeze up inside? No, they all emptied. Yeah.
Like I was surprised, mafic magma is usually it's an effusive type of magma.
Yeah.
So it must be very rich water table on the island that causes the explosive style.
Oh, yeah, but you're right. That's usually it is. It does show that it's mafic magma. So somehow it gets viscous. And it creates this explosive gaseous mixture. Maybe it's the gas, but you may be right. All the water, possibly. Yeah.
What camera equipment were you using on this trip?
Okay, I used 2 different cameras. Most of the scenery, all the scenery pictures were taken with an Olympus OMD M5, and for the eclipse, the Aurora was taken with a Canon 5D Mark IV.
And those are both full frame 35
No, the Canon is a full frame 35 millimeter, and they were all done, and the Auroras were all done on tripods. They're all timed exposures. The other camera is what's called a it's a half frame. It's exactly half the size, and it's made by Olympus or Panasonic. They're the only two that make it. It's half the chip size, which makes the camera half the size or less, and all the lenses and everything are much smaller. So I've kind of adopted that for. It does very good job though, but it's a lot lighter. You know, you could ask Doug what he used. He had Nikon equipment, yeah, lots of people. These happen to be my pictures of the Aurora, but fortunately, everybody who wanted to get pictures got pictures. Because the previous nights where we had the Aurora, they tended to be late at night where it cleared off or something, and not many of us saw it. But this time, it was right at sunset. The ones that I showed you.
So if there are no more questions, and Mike will be here for a couple of minutes if there's something you want to ask, not out loud. But these chairs go this way.